Hi, I'm Paul. We're doing Leetcode Must Know interview questions. Today's challenge is minimum absolute difference in binary search tree, BST. I think this is the first binary search tree problem that we've looked at, although we've had a number of binary tree questions. So this is rated as easy. And the challenge is, given the root of a binary search tree, return the minimum absolute difference between the values of any two different nodes in the tree. All right. Minimum absolute difference. All right, number of nodes in the tree, so there will be no null pointers coming into the method. So it's between 2 and 10 to the 4th, 4 zeros, 10,000, between 2 and 10,000. And the node values will be between 0 and 100,000. Okay? Well, the examples are pretty simple. I mean, we can look at the first one. The thing is, with a binary search tree, the binary search tree, get a pen here, do that color. Binary search tree, if you want to, well, all of the nodes in the left subtree of the root, the values will be less than the value of the root, and every node in the right subtree of the root will have a larger value than the value in the root. And that's it's true of any node, actually. So that's why we can do this recursively. If we pick 2 as the node, and say it's the root of a subtree, well, any values less than 2 will be in the left subtree. There's a 1. Any values greater would be in the right subtree. That's the 3. So we can do an in-order traversal. We can do an in-order traversal of this tree. And if we do an in-order traversal, we're going to get the nodes in order, okay? Now, an in-order traversal is left, root, right. So that means if we get this tree, we traverse it by going to the left first. So from the 4, we would go to the 2, and then we would go to the left. We would get the 1. We would go to the left. We would see that we are at the end. And so then we would get this value right here, 1. Then we would go to the right. There isn't anything to the right, so we would move back up to the so we get the 1. We would move back up to the next node, which is the 2. All right. So we get that node, and then we examine the right subtree of the 2, and there is a 3. We look at the left and right subtrees of 3. There aren't any. So now we are all the way back up at the root. We've got 1, 2, 3. Now we can process this root and get a 4. And we can go to the right subtree of the root. And the only thing over here is a 6. Okay. Now, as far as minimum absolute values, one way to do this, I'm going to take the drawing off. One way to do this is you can do an in-order traversal of the tree. You can take the values out. You could put them in a list, and then you can do subtractions on all of the adjacent numbers. But because the minimum value is going to have to be between, well, the way they say it is, minimum absolute difference between the values of any two different nodes. But the minimum absolute value is going to be between the value of consecutive nodes because we're traversing the nodes in order. So we can also do an in-order traversal and just do the subtractions as we go, which is what we're going to do. And let's see what an implementation would look like. I'm going to start out by defining a couple of class variables. I don't suppose they have to be class variables. I mean, probably you could just pass them around from method to method. We're going to have two methods here, but to me it makes more sense to define them as class values. So let's say 1 is going to be the answer, and we'll initialize it to integer dot max value, something really big so that any answer that we get will be smaller. Okay. The other thing that we need is a tree node pointer. We'll call this previous, and we'll initialize it to null. Why do we need that? Well, because we want to do the subtractions as we're doing the traversal. Now, for example, when we go from the 1 node to the 2 node, when we get to 2, we're going to want to do a subtraction of 2 minus the value of the previous node. But we need a pointer to the previous node in order to be able to do that. And that's the case with every node. We want to do a subtraction, but we need a pointer to the previous node in order to be able to do that. So let's define those. This is going to be, well, actually, let's see. Get minimum difference. We need a recursive method for this. We could call it depth first search because that's what we're doing, but maybe a better name would be in order. We're doing an in order traversal, and we will send in the root, and then we will return A and S. In order is not going to return anything, but it is going to use the class variable of A and S, answer. All right. Let's define a method here. It's void. We called it in order. The input is going to be a tree node, and we could call it node. But since we're using like previous as a variable name, maybe we'll call it current. Okay. It's recursive. So we need a base case, and that would be if current equals null. Current equals null, just return. That is not for the root node. It's when we get down to leaf nodes, like 1, and we try to do recursive calls on the subtrees of 1. Well, there aren't any. So in that case, all we want to do is return. All right. Now, in order traversal, again, is left, node, and then right. So the first thing that we want to do is do an in order traversal on the left subtree. Okay. Let me think about this for a second. Okay, I think we need something here to handle. All right, after we have processed the left subtree, then we are going to process the node. And really the first node, which would be like the 1 in this case, it's a special case. Because when we get to 1, the previous node pointer is still going to be null. That is, there's nothing to subtract from 1. After we process 1, we will always have a previous pointer to an actual node. But for the first time through, we have to handle the case that previous is null. So let's just say if previous is not equal to null, then the answer is going to be the minimum of whatever the current minimum is, and current val, I gotta double check this. Yeah, val. Current val minus previous val. Okay. And we will set previous to current. All right. Now, the only time, as I said, that previous is going to equal null is for the 1 node. We don't want to do a subtraction with the 1 node. Once we get past that, we will set previous to point to the 1 node, and we will go back to the 2 node. Now we want to do a subtraction. We want to do a subtraction. 2 minus 1. Okay. And the last thing that we need to do here is, because an in-order traversal is left node right. We've done the left, we've done the node, we've done the subtraction, but we need to do an in-order on right. Okay. And I think that's it. Right? What are we doing here? We're doing an in-order traversal. We pass in the root. We do a recursive in-order on the left subtree. We then process the node, and we set the previous pointer to current. That is for the benefit of the next node. And then we do an in-order on current dot right. For example, once we process the 2 node, we will set previous to 2 and then do an in-order traversal on the right subtree of 2. Previous will point to 2. We'll get to the 3 node. We'll see that it has no subtrees, and then we'll do a subtraction of current, which would then be 3, minus previous, which would then be 2. Okay? And then we would set 3 to previous, and we would go back up to the root, which is 4, and so on. But anyway, it looks like this is the way to go. So I'm going to try to run it. All right. Accepted. Submit. All right. Good runtime. There are slower ways to do this. As I said, you could take the values out, put them in an array, and then do the subtractions. That would be a little slower. You could, I don't know. Well, I can think of a couple other ways. It would probably be a little bit slower. That don't really involve a. I mean, I guess you could do. Let me think. You know what? It doesn't matter. In order traversal is the best way to do it. Memory was not that good. How did that happen? I bet if I submit it again, it would be better. Where's the memory? Yeah, it's a little bit better. The memory is it's a little bit inconsistent. But yeah, that's it. So in order traversals on binary search trees. Hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.